Welcome everyone. We'll just wait a few minutes so that more people can connect, and then we'll start. Okay, so let's start. Welcome again. I'm Veronica Baelli, Senior Marketing Manager, and with me is Udo Heidl, Principal Product Manager of Model2Go. And today we will talk about this new PTV solution that automates the model building process to deliver a transport model of any city in the world. Udo will introduce us to the product and he will show us some relevant use case. We will address questions at the end of the webinar. You can ask questions by writing them or raising your hand, and I will allow you to speak. After the webinar is over, the webinar is being recorded, and after it is over, I will send a recording to everyone that's signed up for the webinar, so you can review the content of the webinar if you like. All right, then I'll say let's begin.
Thank you very much. Yeah, my name is Udo Heidl. I'm product manager for Model2Go in PTV. I'm working with PTV for almost 33 years, and the largest part of my career, I was a project manager and project director for setting up transport level demand models based on Visum, of course. So, and yeah, and this is, you know, that maybe that this is a quite intensive process, and it's quite takes some long time. And then we had the idea that this process, which is so takes so long and time consuming, we need to automize to make it faster and cheaper at the end. So I will give you a presentation today. First, I want to do two slides about Visum, maybe for some of you, the ones of you who do not know Visum so good. And then I will tell you about this technology, Model2Go, and the creation of transport models. Then I give you some use cases and evaluation examples. And finally, I will focus on a quite big, huge use case. This is a sustainable mobility plans, what the European Union wants to implement in Europe and is going to give guidelines and so on. So let's start. Visum, PTV Visum is PTV's flagship product, you can say. And when I started in 1991, it was already there. I used already still the DOS version of Visum. It looks totally different of the Visum today. But if you ask yourself in the past what Visum means, this is a German shortage. It's Verkehr in Städten Umlegung, which means in English transport in city assignment. So it was at the starting point of Visum, the people who had the idea for Visum, they thought only about assignment of demand to the network. But of course, Visum is meanwhile much more. And you can say Visum is a multifunctional GIS platform for mobility planning. You can do a lot of different use cases or planning, solve a lot of different planning questions in Visum. So it's really, you can say it's the standard office package for transport planning in the world, and you can do a lot of things. So, but what is always everybody should have in mind, if you buy a license of Visum and you open it the first time, you more or less you see an empty screen. Visum is not a transport model. Visum is a toolbox which allows you to build and use transport models. You know, this is the important what you should have in mind. So you need to build a transport model, need a lot of data, and typical data are, I have, as an example now, I have a network model. I need a digital road network model. This is now the example of Munich in Germany. And you need, in most cases, you need also public transport supply model with all the stops and all the lines and all the departure times and a full timetable in the best case. There's a timetable data. And then you can start with, already based on that, you can start with some typically, we can call it GIS functionality, for example, calculation of isochrones around a specific point in Munich, for example, in this case. Or you can also calculate travel times between an origin and a destination. And you see here, I've chosen an origin in the west and then a destination in the south. And Visum gives you then the travel times in public transport, for public transport between this origin and the destination. And in this case, we have a total travel time with public transport. In this case, the route is using the metro in Munich. It's 35 minutes and 7 minutes access time, 21 minutes in the metro, and 7 minutes egress time. Yes, these are only examples, but this is required at least for the base use case application in Munich. So as I said, to provide this database for any city of the world in automated way, this was a learning from the past that it takes, as I said, quite long to implement all this data, and we decided to generate or to develop a technology to do that in an automatic way. And this technology is available now for supply models. And this type of technology is web-based technology for generating routable multimodal maps and georeference socioeconomic data. And this we say to this database transport supply model. And this technology collects automatically and integrates data from either TomTom or here or OpenStreetMap. This is, you can choose that before you start the process. Then it's also OvertureMaps is a new map database from TomTom and other companies, which is currently under development, will be available also in future. So this is a digital road network model. Then we use GDFS data, public transport data from public servers like Transit Land or National Access Point. And then we get a lot of data for point of interest. We will take data from census, from the national census. We will use data from buildings, but we have from OpenStreetMap, data on workplaces. We calculate point of interest data from OpenStreetMap, also for other marketing sources which are used for marketing normally. And we use machine learning methods to improve the data, especially the workplace data. This is what we have a machine learning AI-based approach to generate quite spatial accurate or spatial resoluted workshop data. So, and we can also, for the process, we can also use country-specific data. I said already, census data are mostly country-specific, and also employment data. And we can also integrate data from customers like you. If you have own data, for example, the GDFS data for public transport, which saves the public transport supply. If this data is not public available, for example, in Greece, for some cities, this is the case. But you got it directly from the operator. We can insert this data in the process. And also we can insert FCD data from TomTom or here maps, and we can calculate observed speed, or we will see later observed or demand from these providers like TomTom or here. So the time required for the provision of the automatic generated model, supply model, is 2 to 3 days, and this replaces a manual collection of integration of data into a transport model, which takes normally 2 to 3 months. So this is the time what we win with this automatic approach. And this allows also, and we did it already, a mass production of models. So we can go to the Access web page, PTV Access, where we produced for Germany for 80 cities and for France for 24 departments models which we use to generate data for. So this is also a consequence of Model2Go, that we can use the models for data production for ourselves or for other products. And this is important. So far, I talked only about transport supply models, so the supply part of a travel demand model, but the travel demand model itself is currently not implemented, but we work on that in future to generate also, to add a travel demand model to Model2Go, and to be able to calculate the travel demand and the flow data in the model. This will be done also AI based. So this is you can say our next big task in the next 1 year, 1 or 2 years. So how this is done in a way, if you as a customer wants to get a travel supply model, a transport supply model for Napoli, for example, we have to define the model area. We draw that in Visum, or we can use also administrative boundaries. Then we have to define the desired number of zones. Then this information will be put into the model production process, which is the internal PTV cloud tool. And then after a few hours, the model is finalized, is provided by the cloud service. And you see here, this is the road network of Napoli, and we have the public transport network of Napoli. And there's also other data I will tell you later. So this is the way how it works. So you can order a model for Napoli or for any other region in the world. For example, we have here other examples are Atlanta or Athens or Paris. So if you have a project, or if you have any other reason to require a model for this area, you can define the area with us. Then you give us the order. We can produce a model, and then we deliver the model to you, and you can work on your project in Visum. So what with the components, the components of the Model2Go? One is the road network. So the road network is categorized. So you can differentiate the highways, the major roads, primary roads, secondary roads, access roads. There's a clear road hierarchy inserted into the model. Then we have the free flow speeds which here maps or TomTom maps or OpenStreetMaps have in the data. Then we calculate link capacities based on the number of lanes, and also based on the link category, the link capacity per hour. And we will add elevation data and calculate elevation and great information. The public transport, as said, is that these data are very often, for a lot of cities, already open data. One reason for that this data are open is that there is a delegated regulation from the European Union which says that ITS-related data, multimodal supply data, should be open, and the member states currently provide more and more data on so-called national access points. And for some countries, you can already get this information from the national access points. But there's also an open data platform called Transit Land, where a lot of cities, where a lot of GDFS data are saved and the public transport information can be taken from, and also on other websites. So in a specific case, we will do research where the data are, where the data can taken from, and then we will use this data for the model production. But I said already that if you have own GDFS data, you can also provide them. We can also use the NetX format, which is a European format defined by European Committee for Standardization, but more use the format which is more used is GDFS from Google or General Transport Fee Specification. So this data, public transport data, contain all stop locations, all line routes, all the full timetable for a day or even for a period of days or a period of the validity of the timetable. And this will be integrated into the network. Additional to that, so the demographic data like census data or workplace data, I mentioned that already, we have an AI approach to do a quite good estimation of spatial distributed job data. And we will use the data from OpenStreetMap points of interest and derive for different segments like education, shopping, service, eating out, sport, and personal business. We will derive attraction rates. That is a starting point for the demand model, that you have the attraction rates for every category and every zone, and you have the population data. And this is already a starting point for doing an analysis or to build a travel demand model. So this is also in the Model2Go transport supply, Model2Go supply delivery. Regarding demand, we can also deliver a demand from what we get from TomTom. So in a way, the technical process is as follows: if we have produced a new zone system based on the data what you give us, for example, it's the planning area and the number of zones which should be produced, and then the produced zones will be sent to TomTom. And for this zone system, they will give us back a matrix, and the matrix is, of course, an observed matrix. It contains only car demand. It's only from vehicles where the TomTom device is embedded, and or somebody who uses the TomTom app, the navigation app what they provide. And we observe that the sample size or the number of trips what they have are between 5 and 20% of the trips what we assume which will take place in the planning area. So in Munich, we had around 15% of the trips covered by TomTom. And then you could project this matrix to 100% and do a traffic study. This is one new opportunity to derive demand data, or as you can say, a competitive or a different opportunity in comparison to the travel demand modeling, the synthetic travel demand model. So now some use cases, what you can do out of the box with Model2Go transport, Model2Go supply. So this is, as I said, it's not travel demand model, but you can use it as for accessibility analysis. For example, you need for that the multi-model network, you need for that population workplaces, you need for that points of interest and attraction rates, and then you can calculate different kinds of accessibility analysis in Visum directly. So, and you can use this accessibility calculations also to compare different planning cases, scenarios, without having a demand matrix, but you can do the accessibility analysis to already understand some benefits, what a different measure or new scenario will bring. So this is as an example of an accessibility analysis. We had the question, how many people can access the main station in Munich inside 15 minutes or inside 30 minutes? And what you see here, there is the light blue area is the 15 minutes catchment area for public transport around the main station Munich, and this area covers around 430,000 inhabitants. So, and if you allow 30 minutes, you can even reach 1.3 million of population, almost the whole population of Munich. That means that everybody in Munich can normally reach the main station with public transport in a time of 30 minutes at least. So this is a quite good value. And so you can compare also cities, or you can compare if you introduce a new public metro line, for example. If you have an extension of metro line, you can see what is the accessibility before the introduction of a metro line, or what is after the introduction of a metro line. So this is a similar case. It's not from the main station calculated, but here at the point here in the north of Munich, and the catchment areas of 5 minutes, 10 minutes, and 15 minutes, and the corresponding reached population. So the same thing done for Napoli. Yes, that we have in 5 minutes from the main station, you can reach 67,000 people. 10 minutes, 200,000 people, 50 minutes, 400,000 people, and 30 minutes, 1.1 million people. And the same for Athens, and yeah, it's similar figures. I think it's more or less like in Napoli, a little bit less in 5 minutes, only 20,000 people, but 10 minutes, 150,000, 15 minutes, 400,000, and 1.5 million in 30 minutes. So such analysis you can easily do without any demand, and you can use the Model2Go macro, Model2Go supply for that. Then a use case, what you can also do out of the box, if you add the TomTom demand matrix to the Model2Go supply, then we have a Model2Go demand. We have the network model, for example, road network model. Then we have a FCD matrix or D matrix from TomTom. We can do the assignment. We can project this OD matrix using empirical count data. This count data you have to add to the model, because we normally the count data are not open. We don't know, but you have it in case you have a project, planning project. Most probably you have access to the count data. You can integrate into VSUM, and then you can do a projection using matrix estimation functionality, and then you can do a scenario analysis if you introduce a new road, or you reduce the road, you will degrade, or say that the road is now a bicycle road or anything else. So then you implement the measure, and then you can compare the case before implementation of the measure and after, using the OD matrix from TomTom. I know this is not a travel demand model, but it's a quick way to do a first assessment of the impact of the planning scheme. And then we have a use case. This is maybe the most important use case, is that you use the Model2Go supply as a base, as a starting point, to build a travel demand model. And then you have to add, currently you have to add your survey data, all the trip rates, destination choice, mode choice, the parameters. You have to add by yourself. And then you have to calibrate this trip generation, destination, mode choice, and assignment. Calibrate in a traditional way, you can say, and then you can create a travel demand model. But this part, as I said already, we work on this part. I personally do not think that we really can do an automatic generation of a completely calibrated model, but we can reach a level of 67% of a calibrated model, and this will help and speed up the process of setting up such models in future. This I'm convinced. So now this is the overview about Model2Go and the current status of the Model2Go technology and what you can do with the Model2Go. That's only some examples, but now I talk a little bit about sustainable urban mobility plans. I don't know, because this is a yeah, it's maybe a very important use case of using a transport travel demand model. The European Union sees sustainable urban mobility plans as the cornerstone of European urban mobility policy. So the European, I interpret it in a way that European Union wants that sums will be done around Europe by cities around Europe in a quite similar or comparable way. So that there is a guidelines, and they publish these guidelines for developing, implementing sustainable urban mobility plans already. So, and the European Union Commission strongly recommends that European towns and cities of all sizes embrace the concept of sustainable urban mobility plans. So this is the base. They think, and this is, of course, I also think that can improve the overall quality of life for residents by addressing major challenges related to, and for example, congestion, air noise pollution, climate change, road safety and parking, all what can be addressed in such master plans. And SUMP can also provide a framework for innovation and integration of new mobility service, of course, like ride sharing or mobility sharing or whatever. This new innovative mobility services can also be assessed, and the impact of these modes to the system can be evaluated. So in recent years, already many countries have developed national programs to support the development of SUMs within their national framework. This is important to understand that this is I can say what the European Union recommends or propose, and then the national member states has to integrate this idea in their own national framework. And if we look at Italy, this is from the European Urban Mobility Observatory. There's written that the approach of SUMPs to a strategic urban mobility planning is strictly compliant with the European Commission SUMPs guidelines. Also what Italy or the Italian cities are doing should be strictly compliant with the SUMP guidelines. The SUMP objectives must be measurable by indicators, as stated in this decree, to allow for the assessment of specific contribution to the achievement of national policy objectives. So that means the national policy objectives should be, or the measurement should be assessed if they contribute to the achievement to the national policy objectives. So this is the plan, the overall plan, and it's mandatory that cities, municipalities, more than 100,000 inhabitants adopt the idea of the SUMP or the implementation of a SUMP, excluding those belonging to metropolitan areas that must have their own integrated SUMP. The metropolitan area like Milano or Rome, of course, there other municipalities belong to this area, and there will be therefore all municipalities which belongs to metropolitan area own SUMP should be developed. Starting from 2023, the adoption of a SUMP will be mandatory in order to access funding related to public transport and promotion of cycling programs. This is also important. So if a city wants to get funding, they have to provide a SUMP. This is my interpretation in Italy. So in Greece, what I found is that the law of the number, what you see here, defines a sustainable urban mobility plan based on the definition given in the SUMP guidelines. So this says that the SUMP should be based on the guidelines. It makes mandatory for municipalities over 30,000 inhabitants, as well as for municipalities located within the region of responsibility of Athens and Thessaloniki public transport authorities, and for all regional authorities across the country. Yes. Based on the results of a survey conducted in September 2021, already 120 municipalities were in process of preparing, elaborating or implementing a SUMP. So this is already in process, and more authorities are expected to follow. It's also clear. And it's foreseen that proposed SUMP measures, so what is proposed in the SUMP, will be examined by the Minister of Infrastructure and Transport, and this measure will be used for prioritization in the annual public investment program. So it's also it's connected to some funding. It's not so clear how this will be done as in Italy. So now this is the framework, you can say, of the SUMP in the different member states, in this case for Italy and for Greece. And the question is what travel demand models, what role they play in the SUMP process. The SUMP guideline does not take it mandatory to use this transport model to create a SUMP. So it's not really, it's not as explicitly mandatory. But this decision about whether or not to use a transport model for the SUMP needs to be taken early in the SUMP. So this is clear. So this should already said in the tender documents that the SUMP conduction will need a transport demand model. So, however, transport model is a tool to evaluate scenarios and measures, and this is a key requirement for in the SUMP that you have to evaluate scenarios and measures. This therefore helps to do a prioritization of measures. It's clear. So not using a model might only be an option for smaller cities with limited number of measures that should be evaluated. So this is clear. So if it's a large set of scenarios, a large set of measures, then you need to do a proper prioritization. You need a transport travel demand model. So yes, this is, for me, this is clear. So now I looked at the proposed structure of a SUMP, and you see here at least 3 areas where transport model is required. First of all, there's number 3. Then the mobility situation should be analyzed, should be a weakness analysis, for example. For that, you need to identify some weaknesses. Maybe you define already some performance indicators, and for that you calculate these performance indicators. You need the transport model. Maybe it's an accessibility analysis that shows you which areas in the city are not well connected to public transport. And for this area, if there are some people living there, they cannot use public transport as a mode, then this is so it's maybe a room for analyzing and to add a measure in the SUMP to extend the public transport model to these areas. Build and jointly assess scenarios, and number 7 is select measure package with stakeholders. So the build and jointly assess scenarios, you have to build them, and then you have to compare the different scenarios using some indicators, for example. For that, you need a travel demand model, and also selection of prioritization of measures and together with stakeholders, you should have a tool which gives you indicators to do a proper prioritization. So this is areas where travel demand models might be or should be used. And this is already this is a slide which shows you how, in general, the process will start. At the beginning, the planning process based on a desired vision for the future. The vision could be, we want to have a city which is environmental sustainable and transport systems, and with that everybody can reach their destinations, what they want to go every day in 50 minutes. The so-called 50 minutes city could be a vision. And then from this vision, the objectives can be derived, and then there will be, from the objectives, you derive indicators which can measure if an objective is achieved. Yes. So, and this could be, for example, the average travel time between in the city from the homes to the shops, to supermarkets, or to shops or whatever. So this indicator must be defined, and then for the indicators, targets will be defined. And this way, the scenarios you build for the future, be it a do nothing scenario or a public transport scenario or a bicycle scenario or a sustainable scenario, this can be defined in the SUMP. But the different scenarios must show that, and it should be evaluated how good they really achieve the targets of the vision at the end. So this is the process, and of course, for the indicator calculation for the different scenarios, a travel demand model is the right tool. So this was my presentation. I'm happy to answer questions to you. Thank you very much.
Thank you. Thank you, Udo. Yeah, let's wait a second to see if someone has any question. Okay, so one question that we have is, have you sold already the product to customers, and what is the feedback about the models, if so?
Yeah, we have this product now in the market, so everybody can buy that for more than a year, and we sold it, I don't know the number, but quite often, so maybe 30, 40 times. So, and feedback was mostly positive, but of course we saw, for example, I didn't talk about zoning, creation of zones. I didn't talk about connectors, and all these are components of a transport model. And we saw that that the feedback was that in general it's a good quality, but on some points we saw level or the feedback was that there is some improvements required, and then we checked that, and we find out what the improvement can be for the algorithms, and we introduced it for the next round of programming the tool, and then in the next step it was what the improvement was inserted. So we are learning from the feedback from the customers and make the model or the creation of the model better over the time. But I'm quite sure that this will never end, because there's always in data, integrating data, there's always room for improvement. Of course, one thing is quite difficult, or it's maybe not possible if the base data like here maps have already wrong or not accurate information. We cannot improve the allowed speed on a specific link. If we have the information that 30 kilometers, so for example, 30 kilometers allowed, and in real world this is 50 kilometers allowed. If the information comes wrongly from the providers, then we have not so many means to improve it. Yeah.
Sure. Okay, makes sense. This is a question from me, but are there like future improvement developments that are already planned, or it's just
yes, that's why I mentioned that in the presentation, that especially travel demand model, this is the main use case, you can say, in Visum, that you have a network, a planning area, and you calculate the flows between the zones, yes, in a statistic model, and this is called travel demand model. And this travel demand model requires the distribution of population, the distribution of workplaces, so any information which attracts and generates traffic over the day, because this is the base information to calculate the flows. And then do trip generation, destination choice, mode choice. These are the different modeling steps. And we have started working on the automatic generation of this demand model part. Also, at the beginning we will work on a macroscopic demand model, but we will do also in the further step agent-based demand modeling with that. And this demand model requires also a lot of calibration according or against empirical information like traffic counts, boarding and alightings in the public transport system, or also data from household interview service. So there will be a lot of calibration required. All what is done currently in the manual process, building up such models. This will take a while. It's a big task, but we will do that.
Okay, thank you. Okay, I don't think there are more questions. So maybe we can conclude this a little bit earlier, but I mean, it's fine. Just make sure to follow us on all of our channels, because we will keep having webinars for the customers. And okay, then thank you very much, Udo, and thanks everyone for joining us today. And we'll see you at the next webinar. Thank you very much. Bye-bye.
Thank you very much. Bye bye.